Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra 2 notes, and today we are starting Chapter 6. So Chapter 6 kind of starts out getting us into some exponent rules and things like that. Then we're going to move into some different polynomials. We've looked at quadrilaterals, so we've looked at things that have x to the second power. Now we're going to start looking at things that have x to the third, x to the fourth, x to the fifth powers, all those things. All right, so we're going to kind of break this one into two sections again, 6.1 through 6.4, and then 6.5 through 6.8 is going to be the second part here. All right, so 6.1 is using exponent properties. So my essential question here is, how do I use properties of exponents to simplify expressions? So this 6.1, I'm going to be honest with you, they really kind of put the ball on a tee here for you and to start out the chapter 6, and they let you hit it out of the park. This is a lot of Algebra 1 review. You guys have seen this stuff before. It's just bringing back some of those memories like we've talked about a lot throughout this first semester of Algebra 2. All right, so here all these properties, product of powers rule, all these different rule names. You're not going to really need to know all these names so much in particular, but you do have to know what you have to do when you come up to these things. Okay, so this first one here, if you have the same base raised to different exponents, you can take those exponents and you can actually add them together. All right. So as I look here at this first example, if I have x to the third times x to the fourth, you add 3 and 4 together to give you that 7 for your exponent in the answer. All right, so that's the first one. I'm not going to spend a whole lot of time talking through these guys because I know you guys have seen these before. The second one here, if you have something that's outside of a parentheses here, you can take that and you can distribute it onto both of those. So a to the m, b to the m. Okay, so here I just have that squared, can talk to all three of those guys there. All right, awesome. So then we have a power of a power property. So if you have a power on top of a power outside of parentheses there, you multiply those guys together. So here, if I have x to the second to the fourth power, that's where we multiply those guys together to give me that 8. All right, so a power to a power, you multiply. All right, as we go on to the next couple ones here, anything ever to the 0 power is always 1. All right, so x to the 0 power is 1, 3 to the 0 power is 1, 1,557,000 is 1. Or to the 0 power is 1. I forgot that key part there. Anything to the 0 power is 1. You're going to learn, you're going to be tested on that a lot in the next couple sections here. Negative exponents. What I like to say is that negative exponents are either in the upstairs or they are in the basement. All right, and if they're in the upstairs and they're negative, they're not happy there, so they want to move to the basement. All right, and once they move to the basement, they become happy, they become positive. All right, that's just kind of the way I like to look at it. So here, if I have a to the negative m, that guy's on the top, so he moves to the bottom and becomes positive, so it's 1 over a to the m. Okay, so if we look at an example here, x to the negative third power goes to the bottom and becomes x to the positive 3 on the bottom. All right, but again, if it's negative in the basement, it's not happy in the basement, so it goes to the top and becomes happy. All right, so wherever it's negative, move it around either to the top or the bottom and make it positive. All right, quotient of powers, if you have the same base raised to powers that's on the top and the bottom, you take those guys and you subtract them. So I have x to the 7th over x to the 4th. 7 minus 4 gives me that 3. All right, awesome. Some people like to look at it like this too. If I have x to the 7th, that's really the same as x times x times x times x times x times x times x, so that's 1, 2, 3, 4, 5, 6, 7 over 4 of them, x times x times x times x. So obviously you're not going to do this every time you work one out, but you can say, hey, there's 7 on the top, so I know that this one can cancel with this one can cancel with this one, and cancel with this one, this one, this one. How many are left on the top? 3 of them. All right, so that's why I have x to the third. All right, so if that's the way you like to look at it, go for it. That's awesome. All right, here we go. This guy just says, hey, that exponent can be distributed onto things on the top and on the bottom. So like this 3 talks to everything on the top and everything on the bottom. All right, so again, you guys have seen those in algebra. That shouldn't be anything too new. All right, so here we're going to look at some examples down here that's simplifying some some expressions. But in order for an expression to be completely simplified, we got to have these four things. All right, and I already wrote them in here to save some time. We can have no numbers raised to a power. So we can't have like 2 to the third power in my answer. All right, so that can't happen because 2 to the third power is 2 times 2, which is 4, times 2 is 8. All right, so that's what should be in your answer. All right, 8 should be in your answer. All right, we can have no negative exponents. So you can never have x to the negative 3 power because you can't have this. Remember how we talked about, hey, that goes to the bottom, becomes 1 over x to the positive 3. All right, so that's what you need to write that one as. Number 3, you can have no repeated variables. So if you, like, let's say you have x to the 4th on the top and x on the bottom, we talked about that. If you have 4 x's on the top, 1 x on the bottom, that just simplifies. You can't have this. You have to have x to the 3rd. All right, so you can't see that same base happen more than once. All right, and no parentheses. Let's say we have xy to the 2nd power. You can't keep this in your answer. You need to make that as x squared, y squared. All right. That's what you need to make that into. Awesome. So that's just a couple of those things. Can't have any numbers to a power, can't have any negative exponents, and you can't have any repeated variables or parentheses. Awesome. So let's keep on rolling here with some examples. This one, 3 to the 4th power to the 2nd. Remember here that this is an exponent raised to an exponent. So this is going to be 3 to the 4 times 2. And 4 times 2 is going to be 3 to the 8th power. And we talked about, hey, you can't leave any numbers raised to a power, so you can just throw this in your calculator. 3 to the 8th power is 6,561. All right, so no numbers raised to a power. Number 2, you can distribute this 3 onto both of these guys, so it's going to be 5 to the 3rd over 8 to the 3rd. 5 to the 3rd power is 125, and 8 to the 3rd power on the bottom is going to be 512. If you don't know those things, plug them in your calculator. That's fine. All right, so 512 over, or 125 over 512, can't take anything out of both of those, I believe. All right, so that's my final answer. We're good there. All right, so number 3, we have a couple negatives. We have negative 2 to the negative 3rd power, and we have negative 2 to the 9th power. So there's a couple different ways you can do this. We have the same base raised to different exponents, so I can add these guys together. So this is going to be negative 2 to the negative 3 plus 9, and negative 3 plus 9 is going to be negative 2 to the 6th power. All right, and negative 2 to the 6th power. I do not have this one in my calculator right now, so I got to plug this guy in. Give me a second here. We know that negative 2 to the 6th power, that's going to be a positive answer, because negative 2 times negative 2 is going to be positive, times negative 2 is the 3rd time, is going to be negative. And you guys kind of get the deal. If it's even, it's going to be positive. So if this is even, this is going to be positive. All right, awesome. So let me just plug this in my calculator real quick here. I have, excuse me, 2. Negative 2 raised to the 6th power is 64. All right, so 64 is my final answer there. Awesome. Here we go. As we keep going on, this 3 distributes onto both of these guys. And remember, if it's a power to a power, you multiply them. So this is a to the 6th over b to the negative 9. Excuse me, I got Siri talking to me again. And there we go again. Come back. Keep hitting the button. All right, and negative 3 times 3 is negative 9. And remember, we don't like negative exponents, so that guy flips to the top. This is going to be a to the 6th, b to the 9th on the top, and then there's nothing on the bottom, and that's okay. All right, so we just leave it a to the 6th, b to the 9th. All right, number 5 here. A little bit tricky. We got to go through here. This has got that negative in front of this y, so we got to be careful that the 5 distributes onto the y squared, and technically it goes onto that negative 1. But negative 1 to the 5th power is going to be negative 1 times negative 1 times negative 1 times negative 1 times negative 1, 5 times, which is going to be negative 1. Y to the 10th times y squared times y to the negative 12. All right, and here again you can go through and add all these exponents together because they have the same bases. So I have negative 1 And then I have y to the 10 plus 2 plus negative 12. And we notice here this is going to be negative 1 y to the 0 power. And we talked about this. What is y to the 0 power? Anything to the 0 power is 1, so it's going to be negative 1 times 1, which is negative 1. All right. So add those exponents together to make them 0. Anything to the 0 power is 1. Awesome. So here we go. We got to distribute, get rid of these parentheses on the bottom. So here we go. I have rs to the second over r cubed s to the negative 3. That kind of looks like a 5, but that's an s. All right. I like to get rid of my negative exponents here first. Make those guys positive. I can maybe do a couple steps in one here. I know that I have one r on the top and I have 3 r's on the bottom. So I noticed that 1 r on the top cancels out 1 r on the bottom, but there's still 2 left on the bottom. So I know that my r squared is going to be left on the bottom. And I notice here that I'm going to have s squared and s cubed now, because this turns into a positive when it goes up top. All right, so now s squared and s cubed makes s to the 5th over r squared. All right. Awesome. All right, get rid of those negative exponents and move on from there. All right, as we go on here to the last kind of part of this section is we look at scientific notation. All right, you guys have looked at scientific notation a lot in Algebra 1. If you're going through biology or different things like that, you use scientific notation in those classes as well. So this is just a quick little review. I'm not going to do a whole lot of these, not going to take a whole lot of time on it, but it's a very good way to write very big numbers or very small numbers. All right, so it's most often used in calculations that need to be precise, like in biology or chemistry. There's really, really tiny numbers that really, really need to be precise in order to make that chemical equation balance or whatever it might be. All right, so scientific notation consists of 2 parts. The first is a number. Whoa, I tried to make a number sign there, a hashtag. Number between 1 and 10. Notice it can't be 1 and it can't be 10. All right, so it's in between 1 and 10. So 9.99999 or whatever. All right, and the second part is a power of 10. All right, so example here is 3.56 times 10 to the 4th power. Okay, so now we kind of look at both ways. We look at moving big numbers into scientific notation, or really small numbers into scientific notation, or we go the opposite way around. We move scientific notation into those really, really big or really small numbers. Okay, so the first way, changing numbers from standard form to scientific notation, is that you need to move the decimal point so there's one non-zero digit to the left of the decimal point. All right, so we'll talk about that in some examples here, and we're going to count the number of places that it's going to be moved. And then now here, step number 3 is kind of the big way that I remember this. If the original number is less than 1, the exponent is negative. All right, if the original number is greater than 1, the exponent is going to be positive. So people get confused kind of saying, oh, I got to move right, or I have to move left, or whatever. But I just like to use kind of that main thing is that if it's negative, it's going to be a really, really tiny number. It's going to be like 0.000043 or whatever. If it's got a positive exponent, then it's going to be a very big number like 4,700,000, something. Okay. All right, so let's look at this. So my first number here is this. I have to move my decimal point from here, it comes after that last 0, to 1, 2, 3, 4, 5, 6, 7, 8 times, because I need to make that number in between 1 and 10. So the only number that's in between 1 and 10 is 2.36 times 10 to the, and now I moved it 8 times, so it is to the 8th power. Okay, and my original number is a big number, so that equals a positive exponent. All right, so a positive exponent. This number is a really small number. All right, really small number, 0.0097 or 87. I have to move that decimal place 1, 2, 3 times to make it 9.87 times 10 to the negative 3 now, because my original number is tiny. All right, now here 123, I move my decimal point 2 times to make it 1.23 times 10 to the second. Awesome. All right, now going backwards the other way, move the decimal place to the right if it's a positive exponent, and move it to the left if it is a negative exponent. All right, again, I kind of just like to go back to this number 3 here. If it's a positive exponent, it gets a really, really big number. If it's a negative exponent, it gets really small. Okay, so here I get a negative exponent, so I have to make this guy a really small number, so I move it 1, 2, 3 times. So it's 0.0012. All right, this next one is a positive exponent, so I have to make it really big. 1, 2, 3, 4, 5, 6, 5, 0, 0, 0, 0. 4 zeros on there, and done. All right, awesome. And that last one is 3 times 10 to the first. This is kind of a weird one, but here's the decimal, and it only moves 1 time. And it's positive, so it makes it a bigger number, so this turns into just 30. All right, awesome. So again, thank you for listening to this video. Make sure you hit that subscribe button down below, and we will keep on rolling through the Chapter 6 notes next couple days here. Thanks for listening. Have a good rest of your day.